Hello, friend. I am Neil Tyson, and tonight I will be your guide on a journey through the quiet depths of our galaxy. Come, settle in. Let the weight of the day drift away. Find that perfect position of comfort and release. Allow your body to grow heavy, your muscles to soften, and your mind to become still. Take a slow, deep breath in, filling your lungs with the calm of this present moment. And as you exhale, release everything you no longer need to carry. Let it all go. Tonight, we are voyagers. Our vessel is not one of metal and fire, but one of pure imagination, capable of traveling faster than light, quieter than a whisper. We are setting a course for the space between the stars, that vast, dark expanse that has captured the human imagination for millennia. We often think of it as empty, a perfect void, a silent nothingness. But the cosmos is rarely what it seems at first glance. The greatest truths of the universe are often hidden in the quietest places. The perceived emptiness of space is perhaps the grandest illusion of them all. So breathe in once more, a long, slow breath. And as you breathe out, feel our gentle journey begin. We are lifting away from the familiar blue and white swirl of our Earth. See it grow smaller, a precious marble of life hanging in the velvet black. We drift past our silent, pockmarked moon, our faithful companion. We glide by the rusty red glow of Mars, the sleeping giant Jupiter with its swirling, endless storm, and the serene, majestic rings of Saturn, a celestial jewel box slowly turning. With each planet we pass, feel yourself letting go a little more. The concerns of your world grow more distant, their gravitational pull weakening with every moment. We are leaving the hustle and bustle of the inner solar system behind. We are now passing the orbits of the ice giants, Uranus and Neptune, two faint blue-green pearls in the deep. Our sun is now just the brightest star in a sky overflowing with them. And here, on the edge of our solar system, we feel a change, a subtle shift in the current. We are passing through the heliopause, the invisible boundary where the solar wind, the stream of particles from our sun, finally gives way to the vast ocean of interstellar space. The sun's familiar embrace fades, and we are now truly between the stars. The darkness here is profound, deeper than any night you have ever known. The silence is absolute. It is easy to believe here in this immense expanse that there is nothing, just you, your breath, and the distant, silent fire of a billion suns. But listen with more than your ears, feel with more than your hands. There is something here, a presence, infinitely subtle, yet as vast as the galaxy itself. This is what we have come to explore. Not the void, but the substance. Not the emptiness, but the unseen fullness of what's really between the stars. So relax, let your mind drift. Our journey into the beautiful, grand illusion has just begun. This great expanse we have entered is known as the interstellar medium, a simple scientific name for something so poetic and vast, the medium between the stars. It is not a vacuum, not in the truest sense. A perfect vacuum is an ideal, a concept of absolute nothingness that the universe, in its infinite creativity, seems to refuse to create. The interstellar medium, or the ISM, is the air of the galaxy. It is the repository of old stars and the nursery for new ones. It is the thin, cosmic soup from which everything is born and to which everything returns. Now, when I say it is not empty, you must adjust your sense of scale. Compared to the air you are breathing right now, the interstellar medium is extraordinarily sparse. In the air in your room, in a space as small as a sugar cube, there are trillions upon trillions of molecules. In that same sugar cube-sized volume of interstellar space, you might find a single atom. Sometimes you might find a few. In the denser regions, perhaps 1,000. But often just one, or none. And so the illusion of emptiness is understandable. A vessel traveling through this medium would feel no wind, no resistance. It is the closest thing to nothing our minds can comprehend. But the secret of the interstellar medium is its scale. While a single cubic centimeter contains next to nothing, these centimeters stretch for light years in every direction. They fill the incomprehensible volume between every star in every arm of our Milky Way galaxy. And when you add up all those single atoms over all that unimaginable space, you find something truly substantial. The total mass of the interstellar medium in our galaxy is immense, equal to billions of stars. It is a vast, invisible reservoir of raw material patiently waiting. Imagine you are floating now, weightless in this medium. You feel nothing touching your skin. You see nothing but the pinpricks of distant stars. But now you become aware that this space is filled.
It is filled with a ghostly sea of individual atoms, mostly hydrogen, the simplest and most abundant element in the universe. For every 10 hydrogen atoms, there is about 1 atom of helium. And for every 1,000 of those, there might be a single atom of something heavier, like oxygen or carbon or nitrogen. The very elements that make up you and me and the world we left behind. They are all here, drifting silently in the dark. This gas, this 99% of the interstellar medium, is the galaxy's breath. It flows in slow, majestic currents. It gathers in unseen clouds, hundreds of light years across. It is shocked and heated by exploding stars, and it slowly cools over millions of years, patiently waiting to form the next generation of suns and worlds. You are drifting through the remnants of stars that died long before our Earth was born. The atoms around you have been on a cosmic journey of their own, forged in stellar furnaces, blasted out into space, and now floating here in the quiet dark, ready for their next chapter. But what about the other 1%? That 1% is where the story becomes visible. That 1% is dust, cosmic dust. It may sound small, insignificant, but this 1% is responsible for some of the most breathtaking beauty in the cosmos and for some of its deepest mysteries. It is the spice in the cosmic soup, the pigment in the universal painting. Without it, our night sky would look very different. Without it, we might not be here at all. This dust, along with the gas, is the true substance between the stars, an invisible, ethereal fabric that holds the potential for all that is and all that will be. Let your mind embrace this scale, this quiet fullness. As you float, as you breathe, know that you are not in an empty place. You are in a place of infinite potential, a place of becoming. Let us now turn our gentle focus to that 1%, to the cosmic dust. When we think of dust, we might imagine the simple gray particles that gather in our homes. But interstellar dust is far more ancient and far more meaningful. These are not specks of dirt. They are microscopic grains of history. Each one a tiny, solid artifact from a bygone stellar age. Imagine reaching out your hand into this deep darkness. You would feel nothing. These dust grains are incredibly small, far smaller than a particle of smoke. They are more like complex, microscopic snowflakes of rock and ice. At their core, they often have a tiny bit of silicate, the same family of minerals that make up the sand on a beach and the rock under your feet. Or perhaps their core is made of carbon, the fundamental building block of life itself. Around this rocky or carbon core, in the coldest, deepest parts of space, a fragile mantle of ice is formed. Not just water ice, like in a frosted glass, but also frozen methane, ammonia, and carbon dioxide. A delicate, layered coating, built up atom by atom over eons of drifting through the cold. These tiny, icy, rocky grains are everywhere, mixed in with the vast ocean of hydrogen and helium gas. And though they are small and sparse, their effect is profound. They are the gatekeepers of starlight. As we float here, turn your gaze toward the heart of our Milky Way galaxy. You see a brilliant, dense river of stars. But you will also notice dark, empty-looking patches and lanes cutting through the light. These are not holes in the galaxy. These are not places where the stars have gone out. These are the great molecular clouds, so dense with this cosmic dust that they completely block the light of the stars behind them. The dust forms a curtain, a dark nebula, hiding the galaxy's brilliant core from our simple, visible light eyes. This obscuring effect is happening on a smaller scale all around us. The light from distant stars has to travel through this thin fog of dust to reach us, and the dust affects the light. It is particularly good at scattering shorter wavelengths of light, the blues and the violets. Just as the molecules in Earth's atmosphere scatter blue sunlight to make our sky blue, this interstellar dust scatters the blue light from distant stars. This has two beautiful consequences. First, the light that does get through is missing some of its blue. It appears redder than it truly is. Astronomers call this interstellar reddening. It's why clusters of stars seen through a dusty cloud can look like a smoldering fire of orange and red embers. The dust has stolen their blue light, leaving only the warmer colors to complete the long journey to our eyes. The second consequence is even more spectacular. Sometimes a cloud of this dust happens to be near a bright, young, hot star. The star illuminates the dust cloud, but not like a simple spotlight. The fine dust particles are perfect for scattering the star's blue light in all directions. So, when we look at this cloud, we don't see the star itself.
We see the cloud glowing with a soft, ethereal, second-hand blue light. This is a reflection nebula, a ghostly blue masterpiece painted by starlight on a canvas of cosmic dust. Imagine drifting by one now, a vast, calm, celestial cloud glowing with a serene blue light that seems to come from within its very fabric. It is the universe's way of showing us the unseen, a gentle reminder that even the smallest, most insignificant seeming things can create breathtaking beauty. But this dust does more than just play with light. It is a cosmic matchmaker. The surfaces of these tiny, icy grains are precious real estate in the cold emptiness of space. They act as microscopic meeting places, tiny laboratories where individual, wandering atoms can find each other. A hydrogen atom might land on an icy grain and stick to its surface. A little while later, another hydrogen atom might land nearby. On the cold, stable surface of the dust grain, these two atoms can meet and bond, forming a hydrogen molecule. This is a crucial step. It is far more difficult for two atoms to meet and combine in the emptiness of open space. The dust grain acts as a catalyst, a tiny workbench for cosmic chemistry. It is on these dusty surfaces that simple molecules form, which in turn lead to more complex molecules. Water, ammonia, formaldehyde, and even the building blocks of amino acids have been found in these deep, dark clouds. This cosmic dust is not just a passive screen. It is an active participant in the story of creation. It is the seed from which planets and perhaps even life can grow. Every atom of rock in our planet, every bit of carbon and nitrogen in your body was once part of a grain of interstellar dust, drifting silently, just like this, in the space between the stars. So as you rest here, in this quiet, dusty darkness, feel that connection. You are made of this place. The stardust is not just out there, it is within you. You are a part of this grand cosmic cycle of creation, and this quiet, dark place is your most ancient home. Now, let us allow our awareness to shift once more. We have seen the beautiful effects of the 1% of dust. Let us now turn back to the 99% of gas, the invisible ocean that fills the galaxy. Most of this gas is atomic hydrogen, a single proton with a single electron orbiting it. Simple, fundamental, and everywhere. This gas is so thin and so spread out that it doesn't glow or reflect light in a way our eyes can see. For centuries, we looked right through it, assuming nothing was there. It is a neutral sea, not hot enough to glow on its own, not dense enough to block light like the dusty clouds. So how do we know it's there? How can we map this invisible substance? We listen. We listen for a whisper, a faint cosmic hum that fills the entire galaxy. You see, a hydrogen atom is a beautifully simple system. Its single electron can be in one of two states relative to the proton at its core. You can think of it as the electron either spinning in the same direction as the proton or in the opposite direction. There is a tiny, tiny difference in energy between these two states. The state where they spin in the same direction has just a fraction more energy. Once in a great while, completely at random, an electron in this higher energy state will spontaneously flip its spin to the lower energy state. This is a very rare event for any single atom. It might happen only once in millions of years. But remember the scale of the galaxy. There are so many trillions of hydrogen atoms in the interstellar medium that at any given moment, countless numbers of them are making this little flip. And every time an atom makes this flip, it releases that tiny bit of extra energy. It releases it in the form of a radio wave with a very specific, very constant wavelength of 21 centimeters. This is the hum of the galaxy, a radio signal that is broadcast not by an intelligent civilization, but by the very fabric of the cosmos itself. It is the quiet song of neutral hydrogen. Radio telescopes are our ears, built to hear this song. When we point them at the sky, we can hear this 21-centimeter signal coming from every direction. Where the signal is strong, we know there are vast, dense clouds of this invisible gas. Where it is weak, the gas is thinner. By listening to the subtle shifts in this signal, we can even tell if the clouds are moving toward us or away from us. We can map their rotation, their temperature, their slow, graceful dance around the galactic center. Imagine you can hear it now, a soft, steady, static-like hum in the background of your awareness. It is the most common sound in the universe. It is the sound of peace, the sound of patience. It is the sound of the great neutral sea of hydrogen that ebbs and flows between the stars. This neutral sea exists in different states, like currents of different temperatures in an ocean.
Much of it is what we call the warm, neutral medium. Here, the gas is sparse, with perhaps less than 1 atom per cubic centimeter, and it is warmed by the scattered, diluted light of distant stars to a temperature of thousands of degrees. Now that may sound hot, but because the density is so incredibly low, if you were floating in it, you would feel no heat at all. The individual particles are moving quickly, but there are so few of them that they would transfer almost no energy to you. It is a strange, warm emptiness. But embedded within this warm sea are colder, denser regions. These are the clouds of the cold neutral medium. Here, the gas has clumped together a bit more, perhaps to 20 or 50 atoms per cubic centimeter. Shielded from some of the starlight, these clouds have cooled down to temperatures of hundreds of degrees below zero. They are islands of cold and calm in the warmer, more tenuous medium. It is a dynamic, ever-changing environment. Vast bubbles of hot gas from exploded stars can sweep through, heating and compressing the neutral medium. Gravity slowly pulls on the densest parts of the cold clouds, gathering them together. The entire system is in a slow, constant state of flux, breathing in and out over millions of years. As you drift here now in this invisible sea, feel these gentle, unseen currents. Imagine vast, slow-moving rivers of cold hydrogen, hundreds of light years long, flowing through a warmer, thinner ocean of gas. There is no sound to your ears, but you are attuned to that deep 21-centimeter hum, the fundamental frequency of the galaxy. It is a steady, reassuring presence, a reminder that even in the most seemingly empty places, there is substance, there is structure, and there is a quiet, underlying music. Let this cosmic hum soothe you. It is the lullaby of the Milky Way, sung by the most abundant and humble of its atoms. Breathe with it, float with it. Allow this gentle, universal song to carry you deeper and deeper into a state of profound peace and rest. The galaxy is breathing around you, and you are a part of its slow, quiet rhythm. We have been drifting in a great, neutral sea of hydrogen, listening to its quiet, 21-centimeter hum, a state of calm, of cosmic patience.
But the interstellar medium is a place of grand contrasts. It is not all cool and quiet. Just as an ocean has its warm currents and its deep, cold trenches, the interstellar ocean has its regions of fire and ice. Let us now steer our gentle craft away from the quiet plains of neutral gas and toward the faint inner glow that illuminates parts of the galaxy. Let us explore the fire within. As we drift, we begin to feel a subtle change. A faint, ancient warmth, not from a single star, but diffused all around us, as if we have entered a vast ethereal greenhouse. The gas here is different. It is energized. It is ionized. This means the atoms have been infused with so much energy that their electrons have been stripped away. The hydrogen atoms are no longer a neutral proton and electron pair. They are now free protons and free electrons, a superheated, electrically charged gas called a plasma. Where does this energy come from? Look ahead. In the distance, we see a small cluster of brilliant, searingly bright stars. They are massive and young, blazing with an intensity that dwarfs our own sun. They burn a fierce, brilliant blue-white, pouring unimaginable amounts of ultraviolet radiation into the space around them. This is the source of the warmth. This high-energy light acts like a cosmic wind, washing over the surrounding clouds of neutral hydrogen and tearing the electrons from their atoms. We are entering what astronomers call the warm ionized medium. It is a vast, tenuous plasma with temperatures around 8,000 degrees. Again, the density is so low that this heat is an abstract concept, a measure of the particle's speed, not something you would feel. But you can see its effects. The gas itself is now beginning to glow. It is painting the void with color. This happens because the process of ionization is not a one-way street. While the starlight is constantly stripping electrons away, those free electrons are also constantly finding protons and recombining with them. When an electron is recaptured by a proton, it cascades down through the atom's energy levels, and with each step down, it releases a particle of light, a photon of a very specific color. The most common of these transitions for hydrogen produces a beautiful, characteristic shade of reddish-pink light. It is called the hydrogen alpha line. And as we drift deeper into this region, we see it all around us. The blackness is no longer absolute. It is being replaced by a delicate, transparent veil of glowing rose and crimson. We have arrived at an emission nebula, a stellar masterpiece. Let us drift into one of the most famous, the Great Orion Nebula. Here, the gas is denser and the glow is magnificent. We are floating through vast, swirling curtains of light. Immense, sculptural forms, carved by the radiation and stellar winds from the hot young stars at the nebula's core, rise up like celestial mountains and canyons. We see vibrant reds from the glowing hydrogen, but we also see hints of other colors. The fierce starlight is energizing other elements too. Oxygen, when doubly ionized, glows with a soft, ghostly green. Sulfur shines in a deep, rich red. You are floating in a cosmic cathedral, its stained glass windows illuminated from within. It is not a place of fire in the earthly sense. There is no burning, no smoke. It is a cool, silent fire, a gentle, persistent glow created by the fundamental dance of atoms and light. It is a testament to the power of young stars, their energy so great that it can set a cloud of gas thousands of trillions of miles across alight, turning it into one of the most beautiful sights in the universe. Breathe in this soft, colored light. Let its gentle, silent energy fill your awareness. This is the living, breathing artwork of the galaxy, and you are drifting through its heart. But there is another phase of the interstellar gas, even hotter and more energetic than this. A phase forged not in the steady light of young stars, but in the most violent events the universe has to offer. The explosion of a dying star, a supernova. Let us leave this beautiful, glowing nursery and travel onward, seeking the ghost of such a cataclysm. As we journey, the rosy glow of the nebula fades, and we are back in the thinner, darker medium. But now we are looking for something else, a far more tenuous and far hotter presence. We are looking for the hot ionized medium. This is the rarest part of the interstellar gas by volume, but it is also the most extreme. It has been heated to temperatures of 1,000,000 degrees or more. This incredible heat is the legacy of a supernova. When a massive star ends its life, it explodes with the energy of trillions of suns. This explosion drives a powerful shockwave out into the surrounding space. Imagine a tsunami of unimaginable power and speed, but made of pure energy and matter, plowing through the interstellar gas. As this shockwave expands, it sweeps up, compresses, and heats the gas it encounters to these incredible temperatures. We are approaching such a remnant now. It is almost invisible to our eyes. Its light is not in the visible spectrum, but in X-rays and faint radio waves. But in our mind's eye, we can perceive its structure. It is a vast, expanding shell of superheated plasma, a ghostly bubble, dozens of light years across. We are passing through its ethereal, shimmering wall. The atoms here are moving at incredible speeds, a true cosmic firestorm, yet so spread out, so tenuous, that we pass through without any sense of force. We are flying through the ghost of a star. The energy we feel around us was unleashed in a single brilliant moment tens of thousands of years ago, and it is still echoing, still expanding, still shaping the galaxy around it. Sometimes, multiple supernovae happen in the same region of space, perhaps from a cluster of massive stars that were all born together and die around the same cosmic time. When this happens, their individual remnants merge and combine. Their shock waves reinforce one another, blowing an even larger cavity in the interstellar medium. They create a superbubble, a vast cavern of million-degree gas that can grow to be 1,000 light-years across, pushing aside the cooler gas and dust and reshaping an entire section of a galactic arm. And here is a remarkable thought, a truth to carry with you as you drift deeper into relaxation. Our own sun, our Earth, our entire solar system is currently traveling through one of these superbubbles. It is called the local bubble. For the last several million years, we have been coasting through a region of space that is hotter and less dense than the galactic average. This bubble was carved out by a series of at least 14 supernovae that exploded near our patch of the galaxy between about 2 and 17 million years ago. We are living inside the remnant of ancient cataclysmic explosions. The space our planet journeys through is the echo of stars that died long before humanity ever walked the Earth. We are breathing, in a sense, the air of stellar ghosts. There is no danger. The bubble is old, its energy has spread out, its fire has cooled to a gentle residual warmth. But it is a profound reminder of our place in a dynamic, ever-changing cosmos. The space between the stars is not static. It is a battlefield of creation and destruction. It is a garden where stars bloom and die, and their passing nourishes and reshapes the environment for generations to come. Feel that sense of immense history. Feel the faint, ancient warmth of the local bubble around you. It is the legacy of the stars. It is the cradle of our world.
And it is a perfectly safe and perfectly peaceful place to continue your journey into rest. We have felt the warmth of ionized gas, from the gentle glow of a stellar nursery to the fierce, ghostly heat of a supernova remnant. Now let us seek the opposite extreme. Let our journey take us away from the fire and into the deep, profound cold. We are searching for the cosmic cradles themselves, the places where the next generation of stars is waiting to be born. To find them, we must leave the hot, empty bubbles behind and venture into the darkest, densest, and coldest regions of the interstellar medium. Our vessel glides onward, leaving the faint warmth of the local bubble. We are moving now toward one of those dark lanes we saw earlier, cutting through the river of light from the Milky Way. What looked like a patch of emptiness, a hole in the fabric of stars, is anything but. We are approaching a giant molecular cloud. As we draw closer, the sheer scale becomes apparent. This is not a small puff of smoke.
This is a colossal structure, a celestial continent stretching for hundreds of light years. Its mass is staggering, containing enough gas and dust to form 1,000,000 suns. It is one of the true heavyweights of the galaxy, and it is deeply, profoundly cold. The temperature inside this cloud plummets. We are now in a place that is only 10 degrees above absolute zero, colder than any natural place on Earth, colder than the deepest shadows of Pluto. This extreme cold is essential. The cloud's immense density, packed with all that gas and dust, acts as a shield. The dust grains block the light and heat from distant stars, preventing it from warming the cloud's interior. In this deep, shielded freeze, the universe can perform its most delicate chemistry. Here, in the calm and the cold, the atoms that make up the interstellar gas finally have a chance to meet and join together. As we saw before, the tiny dust grains act as cosmic meeting places. In the frigid environment of a molecular cloud, this process is incredibly efficient. Wandering hydrogen atoms land on the icy surface of a dust grain, and eventually they find a partner, forming a stable hydrogen molecule, two hydrogen atoms bound together. The vast sea of atomic hydrogen we explored earlier has now transformed into a sea of molecular hydrogen. This is why it is called a molecular cloud. This molecular hydrogen, H2, makes up the vast bulk of the cloud, but it is a shy, retiring molecule. It doesn't radiate heat or light in a way our instruments can easily detect. It is, for all intents and purposes, invisible. So how do we know the shape and structure of these colossal invisible clouds? We look for one of its much rarer but much more talkative companions, carbon monoxide, CO. For every 1,000,000 molecules of hydrogen, there might be only one molecule of carbon monoxide. But that one molecule broadcasts a clear, distinct signal in the radio part of the spectrum. It acts as a tracer, a beacon in the dark. By mapping the faint radio glow of carbon monoxide, astronomers can trace the shape, the density, and the movement of the vastly more abundant but invisible molecular hydrogen. It is like trying to understand the shape of a deep-sea creature by observing the few bioluminescent spots on its skin. The CO molecule illuminates the unseen skeleton of the galaxy. Let us now drift inside this immense, cold, and dark cathedral. The last of the distant starlight is extinguished by the thick dust. The blackness here is absolute, a perfect velvet void. There is a sense of profound stillness, of immense pressure and weight all around you. You are inside the raw material of creation. As our senses adjust to the deep dark, we begin to perceive structures. The gas is not uniform. It is clumpy, arranged in dense filaments and knots. Gravity is at work here. In the deep cold, the frantic random motion of the gas particles has slowed to a crawl. The gentle, persistent pull of gravity, which was easily overcome in the hot, energetic regions, can now begin to assert its authority. It is a slow-motion battle fought over millions of years. The outward push of the gas pressure versus the inward pull of gravity. In the densest knots of the cloud, gravity is winning. We are floating now toward one such knot. It is a small, particularly dark region called a Boak globule. It appears as an inky black hole against a faint background glow from a more distant nebula. It is a cocoon, a cosmic egg. Inside this dense, cold sphere of gas and dust, a star is beginning to form. Let us drift closer still, to the very heart of this collapsing core. The material is spiraling inward, slowly at first, then faster and faster, like water going down a drain. As the gas and dust fall inward, it begins to heat up. The energy of the collapse, the gravitational potential energy, is being converted into heat. At the very center, a hot, dense kernel is forming. This is a protostar.
A star in its infancy. It is not yet a true star. It is not yet shining by the power of nuclear fusion. It is shining only with the light and heat of its own contraction. It is a dull, red glow, completely shrouded from the outside universe by the thick, dusty cocoon that is still feeding it, still helping it to grow. Around this glowing protostar, a disk of leftover gas and dust is forming, a protoplanetary disk. Within this swirling, dusty disk, the seeds of future planets are being sown. The tiny dust grains are beginning to stick together, growing into pebbles, then rocks, then boulders, and one day, over millions of years, into new worlds. We are witnessing the very beginning, the dawn of a new solar system. Here, in the coldest, darkest, quietest place we have yet visited, the potential for light, warmth, and life is being realized. It is a place of deep peace, of slow, patient, and powerful creation. There is no rush. The universe is taking its time, crafting a new sun and its family of planets from the ancient dust and gas of the galaxy. Let this feeling of serene, powerful creation fill your being. The entire universe is a cycle of renewal. Out of the cold and the dark, new light is always being born. And in this moment, you are here to witness it. Rest in this cosmic cradle. Feel the stillness, the anticipation, the promise of a star about to be born. We have journeyed through the substance of the interstellar medium, the gas, the dust, the hot, the cold. We have seen the matter that fills the space between the stars. But the story is not yet complete. The interstellar space is also alive with unseen energies and invisible forces that shape and define it. Let us now turn our awareness to this unseen river of energy, to the cosmic rays and magnetic fields that flow through the void. First, let us consider the cosmic rays. The name is a little misleading. They are not rays of light like X-rays or gamma rays. They are physical particles, mostly protons, the nuclei of hydrogen atoms, along with the nuclei of helium and other heavier elements. And they are moving at unimaginable speeds, close to the velocity of light itself. Imagine a single proton, a particle so small it is almost pure concept, imbued with the energy of a professionally thrown baseball. That is a cosmic ray. They are the fastest moving bits of matter in the galaxy. They are a constant, invisible rain, a drizzle of hyper-energetic particles falling through every corner of interstellar space. Where do they come from? How are they accelerated to these incredible speeds? The primary engines for this are the very same events we witnessed earlier, supernovae. The expanding shock wave from an exploding star is a particle accelerator of galactic proportions. As the shock wave plows through the interstellar gas, its turbulent magnetic fields can trap particles, bouncing them back and forth across the shock front again and again. With each bounce, the particle gains more energy, moving faster and faster, until it is finally kicked out into the galaxy at nearly the speed of light. For millions of years, these particles then travel, zipping across the void. As you float here in this peaceful state, billions of them are passing through our imaginary vessel, and indeed through your room and even your body every second. They are so small and so fast that they pass through harmlessly, their passage entirely unnoticed. They are the silent, energetic ghosts of the cosmos, a constant reminder of the violent, powerful events that shape our galactic environment. But these cosmic rays do not travel in perfectly straight lines. Their paths are bent and twisted by the second great unseen force of the interstellar medium, the galactic magnetic field. Imagine an invisible web, a mesh of force lines threading through the entire Milky Way. This is the galaxy's magnetic field. It is incredibly weak, thousands of times weaker than the magnetic field at the Earth's surface that guides a compass. If you were floating in space, you would feel no pull from it at all. But like the interstellar gas itself, its power comes from its immense scale. It stretches for 100,000 light-years, a cohesive structure that influences the entire galaxy. This magnetic field is woven into the very fabric of the interstellar plasma. The charged particles of the ionized gas cannot easily move across the magnetic field lines. Instead, they are forced to spiral along the magnetic field lines. The field and the gas are tied together. Where the gas goes, it drags the magnetic field with it. And where the magnetic field is strong, it can channel the flow of the gas, like the banks of a river guiding the water. This intimate connection between the gas and the field is what guides the cosmic rays. These high-energy particles are charged, so they too are caught by the magnetic field.
One word is warning for those of you watching on the live after-hours broadcast on Astrofire. These cosmic rays do not travel in perfectly straight lines. Their paths are bent and twisted by the second great unseen force of the interstellar medium, the galactic magnetic field. Imagine an invisible web, a mesh of force lines threading through the entire Milky Way. This is the galaxy's magnetic field. It is incredibly weak, thousands of times weaker than the magnetic field at the Earth's surface that guides a compass. If you were floating in space, you would feel no pull from it at all. But, like the interstellar gas itself, its power comes from its immense scale. It stretches for 100,000 light-years, a cohesive structure that influences the entire galaxy. This magnetic field is woven into the very fabric of the interstellar plasma. The charged particles of the ionized gas cannot easily move across the magnetic field lines. Instead, they are forced to spiral along the magnetic field lines. The field and the gas are tied together. Where the gas goes, it drags the magnetic field with it. And where the magnetic field is strong, it can channel the flow of the gas, like the banks of a river guiding the water. This intimate connection between the gas and the field is what guides the cosmic rays. These high-energy particles are charged, so they too are caught by the magnetic field.
They are forced to spiral along the invisible lines of force, their journeys turned from straight sprints into long, meandering odysseys through the galaxy. The magnetic field acts as a vast circulatory system, distributing this high-energy particle radiation throughout the galactic disk. We can see the effect of this magnetic field in the structure of the cosmos. When we look at certain nebula, we can see long, thin, filamentary structures. These are often clouds of gas and dust that have been shaped and compressed by the galactic magnetic field. The field lines, stretched and tangled by the movement of the gas, act as a kind of cosmic loom, weaving the raw material of the ISM into intricate patterns. Even in the birth of stars, this magnetic field plays a crucial role. Within the cold, dense molecular clouds, the magnetic field provides a kind of support. It creates a magnetic pressure that pushes outward, working against the inward pull of gravity. This can slow down the collapse of a cloud, regulating the pace of star formation. A star cannot be born until the grip of gravity in a small, dense clump becomes strong enough to finally overcome this magnetic resistance. It is a delicate, cosmic balancing act between matter, gravity, and magnetism. And on the grandest scale, this magnetic field is thought to trace the beautiful spiral arms of our galaxy. The field lines run roughly parallel to the arms, helping to organize the flow of gas and dust that makes these structures so prominent. The spiral arms are not just collections of stars, they are dynamic waves of star formation, and their structure is guided in part by this unseen magnetic architecture. So as you continue to drift, become aware of these invisible forces. Feel the silent, harmless passage of the cosmic rays, each one a tiny messenger from a long-dead star. And sense the gentle, directional guidance of the magnetic field, a vast, galaxy-spanning current in the interstellar ocean. You are floating not in a simple emptiness, but in a dynamic, living environment. An intricate ecosystem of matter and energy where everything is connected. The gas clouds shape the magnetic field shapes the gas clouds, and the explosions of old stars send energetic particles racing along these magnetic pathways, carrying energy to all corners of the galaxy. It is a complex and beautiful system, working in perfect, silent harmony. Let the thought of these unseen, organizing forces bring you a sense of peace. There is a hidden order, a quiet structure to everything. And you are a part of it, floating safely within its embrace. Our journey so far has been one of immense scales, drifting through the varied and beautiful landscapes of the interstellar medium. We have felt the chill of molecular clouds and the ancient warmth of supernova remnants. We have seen the universe painted with the light of glowing gas and shrouded by the curtains of cosmic dust. We have listened to the quiet hum of hydrogen and felt the unseen guidance of magnetic fields. But this has been a journey of the mind, a guided dream through the cosmos. Now let us bring our story a little closer to home by following in the footsteps of humanity's most distant explorers. Let us take a voyager's perspective. Back in the year 1977, a time that feels both recent and long ago, humanity sent two messengers out into the grand dark ocean. They were the Voyager 1 and Voyager 2 spacecraft. Small, robotic emissaries, extensions of our own senses, our own curiosity. They were built to last, powered by the slow decay of radioactive elements, designed to whisper their findings back to us across unimaginable distances. Their initial mission was a grand tour of the outer planets, and they performed it flawlessly, revealing the wonders of Jupiter, Saturn, Uranus, and Neptune in breathtaking detail. But their journey was never meant to end there. Their trajectory was a one-way ticket, an endless outbound arc into the great unknown between the stars. For decades, they have traveled in silence and darkness. Two of the most remote objects ever created by human hands, sailing farther and farther away from the dwindling light of our sun. Let us join them now. Let us match our speed and position with Voyager 1, the faster and more distant of the two. We are now billions of miles from home, far beyond the orbit of the most distant planet. The sun is just a star here, albeit the brightest one in the sky. Its warmth is gone, its light is faint, but its influence is not. We are still traveling within its kingdom. We are still inside the heliosphere. The heliosphere is a magnificent, invisible structure. It is a vast bubble blown into the interstellar medium by our own sun. The sun is constantly breathing out a stream of charged particles, protons and electrons, known as the solar wind. This wind travels outward in all directions at 1,000,000 miles per hour.
It is this solar wind that inflates the heliosphere, pushing back against the interstellar gas and creating a protected space, a local cocoon for our solar system as it journeys through the galaxy. Imagine you are at the shore of a calm lake and you place a small fan on the sand, pointing out over the water. The fan creates a breeze, a small area of moving air that keeps the lake's gentle mist at bay. The heliosphere is like that breeze, and the interstellar medium is the mist. Our sun is the fan, and for billions of miles in every direction, its breath is the dominant force. As we drift along with Voyager, we can feel this solar wind. It is not a wind you could feel on your skin. It is a tenuous, almost intangible stream of particles. But Voyager's instruments can feel it. For more than 30 years, they measured this wind, this constant outflow from our home star. But as we travel farther out, the wind begins to slow. It is running out of energy, beginning to feel the pressure of the interstellar medium pushing back. We are approaching the first of several boundaries, a place called the termination shock. This is where the solar wind, which has been traveling at supersonic speeds, suddenly slows down and becomes denser and hotter. Imagine the smooth, fast flow of a river suddenly hitting a wide, calm lake. There would be turbulence, a shock wave. It is the same here on a cosmic scale. Voyager 1 crossed this boundary in 2004, a momentous, quiet event that signaled we were entering the outer frontier of the sun's domain. Beyond the termination shock, we enter a vast, turbulent region called the heliosheath. Here, the solar wind is no longer flowing in a straight line away from the sun. It is a chaotic, churning region where the sun's breath is deflected and flows sideways, like smoke hitting a ceiling, moving toward the tail of the heliosphere. We are in the boundary lands, the final buffer zone between our home and the galaxy at large. The space here feels different. The sun's influence is waning, and we can begin to feel the presence of the great interstellar ocean just beyond. For years, Voyager 1 traveled through this turbulent sheath, patiently reporting back on the strange conditions. The sun's magnetic field, carried outward by the solar wind, became jumbled and foamy. The particles from the sun were mixing with the particles from the galaxy, which were beginning to leak in. We are approaching the final edge, the very last line of defense, a boundary called the heliopause. This is the place where the pressure of the solar wind finally becomes equal to the pressure of the interstellar wind.
It is the invisible curtain where the sun's breath finally stops and the true breath of the galaxy begins. Let us slow our imaginary vessel and watch as Voyager 1 approaches this momentous threshold. For months, its instruments reported strange and wondrous things. The solar wind particles, the familiar messengers from our sun, began to disappear, their numbers dropping to almost nothing. At the same time, the instruments began to register a dramatic increase in the intensity of another kind of particle, the galactic cosmic rays. Remember those high-energy particles forged in distant supernovae that rain down throughout the galaxy? The heliosphere, with its outward-pushing solar wind and magnetic field, acts as a shield, deflecting many of these cosmic rays away from our solar system. It protects us from the harshest of the galactic radiation. But here, at the very edge, that shield is falling away. The roar of the galaxy, in the form of these cosmic rays, is growing louder and louder. And then, in August of 2012, it happened. Voyager 1's instruments reported a sudden, sharp, and permanent change. The solar wind particles vanished completely. The intensity of the galactic cosmic rays jumped to a new, high and steady level. The direction of the magnetic field around the spacecraft shifted, no longer pointing away from the sun, but aligned with the broader magnetic field of the galaxy. In that quiet, unobserved moment, more than 11 billion miles from home, a small machine built by human hands slipped through the invisible curtain. It had left the heliosphere. It had passed through the heliopause. Voyager 1 was now, officially, and for the first time in human history, flying in interstellar space. Let us make that crossing ourselves now. Feel the transition. It is a moment of profound peace and significance. On one side of the boundary, the faint but familiar push of our sun's wind. On the other, stillness. The solar wind is gone. We have left the river of our star and entered the great, still ocean of the galaxy. The energy we feel now is different. It is older, wilder. It is the unshielded energy of the cosmos itself. The silent, steady rain of cosmic rays tells us we are no longer in our protected harbor. We are on the open sea. And what did Voyager taste in this new environment? What was the first direct measurement of the space between the stars? Its instruments found that the plasma, the ionized gas of the interstellar medium right outside our bubble, was much denser than scientists had predicted. It was also cooler. We had expected to emerge into a hot, tenuous region, but instead we found a warm, surprisingly dense plasma. And the galactic magnetic field was stronger than we thought, pressing in on our heliosphere, causing it to be smaller than our models had suggested. These were the first direct samples of the interstellar air, the first time we had dipped our toe in the cosmic water. And it taught us that our theories, our models, are always incomplete. The universe is always ready to surprise us. As we float here, alongside this tireless, silent explorer, we feel a deep connection. Attached to the side of Voyager is a golden record, a message in a bottle. It contains sounds and images from Earth. The sound of wind and rain, the songs of birds and whales, music from different cultures and eras, and greetings in 55 languages. It is a portrait of our world, sent out into the vastness with a faint hope that sometime, somewhere, another traveling civilization might find it. For now, its only audience is the silent, patient substance of the interstellar medium. The gas, the dust, the cosmic rays, the magnetic fields. We have sent a piece of ourselves, a story of who we are, into the very heart of the subject of our journey tonight. This small spacecraft is a testament to the human desire to reach out, to understand, to connect with the universe. And as it continues its endless journey, traveling for tens of thousands of years before it even comes remotely close to another star, it reminds us that we are a part of this great expanse. We are not just observers of the cosmos, we are participants. We are the universe, grown curious. Let this peaceful, momentous achievement fill you with a sense of calm pride and wonder. Humanity has touched the space between the stars.
And in doing so, we have learned a little more about our place in the magnificent and far from empty void. Now, let us begin the final stage of our journey tonight. We have traveled from our home planet out past the farthest reaches of our sun's influence and into the local interstellar medium. We have explored the stuff between the stars in our little corner of the galaxy. But our galaxy, the Milky Way, is just one island of stars in an archipelago of hundreds of billions. To complete our understanding, to truly grasp the scale of connection in the universe, we must zoom out one last time. We must broaden our perspective from the interstellar to the intergalactic. Let your awareness expand. Our imaginary vessel is now capable of traveling millions of light years in an instant. We pull back and back and back. Our entire Milky Way galaxy, with its beautiful spiral arms, its glowing nebula, its dark molecular clouds, shrinks to become a small, luminous pinwheel. We see its neighbors, the Andromeda Galaxy and the Triangulum Galaxy, and dozens of smaller dwarf galaxies, all part of our local group. But we keep pulling back. Our local group becomes a small, insignificant cluster. We see other clusters of galaxies, like the Great Virgo Cluster, a sprawling cosmic metropolis containing over 1,000 galaxies. And we continue to pull back. Clusters themselves become mere points of light. We are now viewing the universe on the largest possible scale, a canvas billions of light years across. And what do we see? Is it a random scattering of galaxies like dust motes in a sunbeam? No, the universe is not random. On this grandest of scales, we see a structure, a magnificent, breathtaking, and utterly beautiful structure. We see the cosmic web. Imagine the universe is a vast, dark space, and someone has strung it with the most delicate, luminous threads of a spider's web. This is the sight before us. Matter in the universe, both the normal matter we can see and the invisible dark matter that provides the gravitational scaffolding, is arranged in this colossal, interconnected network. Let us explore the components of this web. First, there are the great, dark regions in between the threads. These are the cosmic voids. They are the largest structures in the universe, vast, nearly empty bubbles hundreds of millions of light years across. They are not a perfect vacuum, but they are incredibly sparse, containing very few galaxies and almost no gas. As we drift into one of these voids, we experience a quiet and a solitude that is even more profound than the space between the stars. The light from the great filaments of the web is faint and distant. It is an abyss of deep, peaceful darkness, a place of cosmic meditation. But let us drift back now, toward the light. Let us approach one of the glowing threads of this web. These are the cosmic filaments.
These are unimaginably long, thin rivers of gas and dark matter, stretching for hundreds of millions of light years, flowing through the voids and connecting everything together. The substance that fills these filaments is what we call the intergalactic medium, the stuff between the galaxies. Specifically, much of it is in a state known as the warm-hot intergalactic medium, or WIM. It is a very thin, very hot plasma, similar in some ways to the hot, ionized medium we found inside supernova bubbles in our own galaxy, but far, far more tenuous. It is so thin and faint that it is incredibly difficult to detect. For a long time, it was known as the missing matter in the universe because our theories predicted it should be there, but we could not see it. Only recently, with our most sensitive instruments, have we been able to glimpse the faint glow and absorption of this gas, confirming that these great cosmic rivers are real. Let us float along one of these filaments now. It is like being in a slow, majestic current. All around us is this thin, warm, hot plasma. It is the reservoir from which all galaxies are born. Gravity slowly, patiently pulls gas from these filaments, and this gas trickles down into the galaxies, providing the raw fuel they need to form new stars. Our own Milky Way is constantly being fed by a gentle stream of this intergalactic material. It is the universe breathing in. At the same time, the galaxies are breathing out. When massive stars explode as supernova, or when supermassive black holes at the centers of galaxies erupt with energy, they can drive powerful winds that blow gas and heavy elements out of the galaxy and back into the intergalactic medium. This enriches the filaments with the carbon, oxygen, and iron that were forged in the hearts of stars. It is a grand cosmic recycling program. The universe wastes nothing. And where these great filaments of the cosmic web intersect, where the rivers meet, we find the busiest, most brilliant parts of the universe. We find the great clusters and superclusters of galaxies. These are the nodes of the web, vast, dense knots of thousands of galaxies, all orbiting each other, held together by an immense concentration of dark matter. From our peaceful vantage point, a galactic cluster is a stunning sight, like a celestial chandelier, a dense swarm of brilliant shining galaxies. And where do we fit into this grand scheme? Our own Milky Way galaxy, our home, is not in one of the great voids, nor is it in a crowded, bustling cluster. We reside in a quieter part of the cosmic web. Our local group of galaxies is situated on one of the smaller, calmer filaments, a sort of cosmic country road that connects the nearby Virgo cluster to other, more distant structures. We live in the peaceful suburbs of the universe. As you float here, taking in this ultimate cosmic perspective, let a profound sense of connection wash over you. Everything is part of this web. The atoms that make up your body, the air you breathe, the planet you live on, were forged in a star. That star was born from a molecular cloud within our Milky Way galaxy. Our galaxy draws its lifeblood from a great filament of intergalactic gas. And that filament is part of a universal, interconnected web that stretches across the entire observable cosmos. There is no true emptiness. There is no true isolation. From the tiniest grain of interstellar dust to the largest cosmic void, it is all part of one single, magnificent, and evolving structure. The space between the stars is not a void to be crossed, but a substance that connects. The space between the galaxies is not an empty chasm, but a river that feeds and nourishes. You are not separate from this. You are a part of it. You are a thinking, feeling, dreaming piece of this cosmic web, temporarily assembled into a human being, looking out and trying to understand itself. And in this moment of quiet understanding, there is a deep and abiding peace, the peace of belonging, the peace of knowing your place in the grand, breathing, interconnected whole. The universe is not a cold, empty place. It is a rich, dynamic, and beautiful tapestry, and you are woven into its very fabric. Let this final, vast image be your vessel as you drift now towards sleep. See yourself as a part of this shimmering, cosmic network. Feel the slow, steady rhythm of the universe breathing around you. The gentle currents of the interstellar medium, the majestic flow of the intergalactic rivers, all of it is part of one great harmonious system. And you are a part of it too. Perfectly placed, perfectly connected, perfectly at peace. Our grand tour is coming to a close. From the infinite expanse of the cosmic web, let our awareness now begin its gentle journey home. The great shimmering filaments of galaxies, the vast, quiet voids, let them recede, like the memory of a beautiful dream.
Feel your perspective shrinking, returning from the intergalactic to the familiar. We drift back toward our own cosmic neighborhood, our little filament on the edge of the Virgo supercluster. We find that small, intimate gathering of galaxies, our local group. And there, shining with a soft spiral light, is our home, our Milky Way. As we draw closer, its pinwheel form resolves into the structures we have come to know. We see the dark lanes of dust, no longer as empty patches, but as the rich, fertile soil from which new stars are grown. We see the pinkish-red glow of emission nebulae, the cosmic nurseries where that dust is set alight by the passion of newborn suns. We see the ethereal blue haze of reflection nebulae, where starlight scatters like a soft mist. Our imaginary vessel glides back into the spiral arm we call home.
We pass through the vast, invisible clouds of hydrogen, their quiet 21-centimeter song a constant, soothing hum in the background. We feel the faint, ancient warmth of the local bubble, the ghost of supernovae that cleared this path for us long ago. We sense the gentle, unseen currents of the galactic magnetic field, the architecture that guides and shapes this place we call home. Ahead, a single, bright star grows more brilliant, our sun, and we feel its familiar breath once more as we slip across the heliopause. We are leaving the wild, open ocean of interstellar space and re-entering the protected harbor of our solar system. The gentle push of the solar wind is a familiar welcome. The intense rain of cosmic rays softens, shielded by our star's magnetic embrace. We glide past the orbits of the ice giants, Neptune and Uranus. We pass the majestic rings of Saturn and the swirling storms of Jupiter. We see the faint, ruddy light of Mars, and ahead, a beautiful, swirling jewel of blue and white and green, our Earth, our home. Our journey tonight has taken us across light years and back again. We have seen that the great, dark night is not an emptiness to be feared, but a fullness to be understood. It is a dynamic and creative place, a grand and beautiful tapestry woven from gas and dust, light and gravity, fire and ice. It is a place of constant, patient creation. The space between the stars is not a void, it is a womb. And it is from this substance, this stardust, this recycled breath of the cosmos that we are made. Every atom in your being has taken this journey. You are a child of the interstellar medium. And now, as your awareness settles back into the comfort of your room, into the gentle rhythm of your own breathing, know that you are connected to all of it. The quiet strength of the molecular clouds is within you. The patient cycle of creation and renewal is your own story. You are not separate from the universe. You are the universe experiencing itself. And just as the cosmos finds its balance between energy and quiet, between the brilliant fire of stars and the deep peace of the void, so too can you find your own balance now. Let the energy of the day recede. Let the deep, profound peace of the night settle over you. There is nothing left for you to do but rest. Nothing to solve, nothing to hold, just the gentle gravitational pull of sleep, drawing you down into a state of deep and restorative peace. The galaxy will continue its slow, graceful dance. The stars will continue to be born from dust. And you can release yourself to the quiet, trusting in the cycles of night and day. You are safe. You are connected. You are made of stardust and wonder. And it is time now to rest. Breathe in the peace of the cosmos. And breathe out, letting go, drifting now into a deep and dreamless sleep. Good night, friend. Sleep well.